Hi everyone, this video is on question 10 of exercise 9H from Pure 2. We have the equation of the curve sine x plus cos y is equal to a half, where the values of x and y are both between pi and minus pi. So in part A, we want to find the derivative of sine x and cos, the function. So this is an implicit differentiation, and we first differentiate sine x, which differentiates to cos x, and cos y differentiates to minus sine y, but it also has the term divide x because this is y is a dependent variable, so that's why we always write down divide x after the derivative, and the half differentiates to 0. So this is basically the derivative, and we can rearrange that to have in a nicer form. So this is equal to minus cos x, and we divide both sides by minus sine y. So we have divided x in terms of x and y, which is cos x divided by sine y. So this is the derivative and the answer to part A. In part B, we are asked to find the coordinates of the stationary points on C. So whenever we want to find the coordinates of the stationary points, we need to solve the equation of divide dx is equal to 0. And the solutions to that equation give us the values of the coordinates of the stationary points. And in this case, divide dx is equal to 0 means cos x divided by sine y is equal to 0, which is equal to cos x equal to 0. And we just need to solve this equation. Also note that the values of x are between pi and minus pi, because this is crucial for our equation, because that means the values of x are simply plus or minus pi over 2, because these are the only values in that domain that are going to give us the value of 0 if we have cos of pi over 2 or minus pi over 2. So what does this mean for us? Now this means that we now have to substitute these coordinates, x coordinates of the stationary points, into the main equation of the curve, which is this. And by doing so, we can find the values of the coordinates of the y coordinates of the stationary point. So we first we can substitute pi over 2 and then minus pi over 2 afterwards. So when x is pi over 2, we are going to have, so sine x is sine pi over 2, which is 1, plus cos y is equal to a half. So we are going to get 1 plus cos y is equal to a half, which means cos y is equal to minus a half. So, and now if we solve this, again, we use the fact that y is between pi and minus pi. So this gives us the values of plus or minus 2 pi over 3, because these are the only values that will make cos y 0 in that domain, or in that range basically. So at this point, we have two different values for y. So this basically means that one stationary point is when x is pi over 2 and y is 2 pi over 3, and the other stationary point is when, again, x is pi over 2 but y is minus 2 pi over 3. So basically there are two stationary points with different y coordinates but with the same x coordinate. But this is not the end of the story. Remember that we had the x of minus pi over 2, so we also need to substitute that into the equation of C. When x is equal to minus pi over 2 this time, again, so we have sine minus pi over 2 plus cos y is equal to a half. And this is crucial because sine minus pi over 2 is basically minus 1, and we'll have minus 1 plus cos y is equal to a half, which means cos y is equal to minus 1.5. And this doesn't have any solutions, because remember that sine and cos functions, the output of cos and sine functions is always between -1 and 1. But in this case, the output here is minus 1.5, which is basically less than -1. So this equation doesn't have any solutions. And that simply means that when we don't have basically any stationary points with such information that the x coordinate is minus pi over 2, because there are no corresponding y coordinates. And that only leaves us with the two stationary points. So the stationary points have these coordinates. So both of them have the coordinates of pi over 2. And the only difference is that one of them has the y coordinate of plus 2 pi over 3, but the other one is minus 2 pi over 3. So these are the stationary points. Okay, so thank you for watching. I'll see you in the next video.